Okay, good morning. We have a Master-bilt cake freezer. There are two of them. This one is 0 degrees, this one is high temp. They said yesterday morning it was dead. Coil's cleared up. Yeah, coil's clear because it's 85 degrees in here. The fans were spinning. Now, must have an issue up top. Let's dig in and see what's going on up there. Okay, so I checked the breakers, power was on. I came up here and my condenser fans are spinning. My compressor's not. If you wait long enough, we'll catch it. The compressor is trying. So this is not short cycling like we would normally say, oh, the unit's short cycling. So when the unit is short cycling, if it was low on pressure, that was the compressor trying to start. If it was low on pressure or high head pressure, it would actually be shutting down the fans. So the fact that the unit is calling for cooling, everything from an independent equipment standpoint has been told to run, it just won't run. So my compressor won't run. So I open up the electrical panel because it uses start components, right? So here's my electrical panel. And I don't know if you can see the obvious crime scene here. This capacitor has melted down and it blew up, literally blew its top and splattered its innards all over the place. So that is not getting what it needs to start. So now that we know what's going on, I'm going to pull the disconnect. Okay, that'll stop the compressor from short cycling, kill my power. I'm going to go ahead and document what all of these are. If I'm going to replace this capacitor, I'm going to replace all the capacitors. So I'm going to get these two capacitors and this potential relay, which we should be able to get all locally at United. The relay, I may have to get them to cross-reference. If you take a picture of the model number, serial number of the unit, take a picture of the actual compressor information, take that to the local parts house, and they can cross-reference exactly what you need and make sure you get the right thing. So when it comes to the capacitors, right, so the numbers you're looking for, right? So this is an 88 to 106 microfarad capacitor, 330 volts, 50 to 60 hertz. So I would always suggest just take a picture of it, take it to the parts house. Don't take it off, because leave the wiring set up like it is, right? If I actually unplug all this stuff, then I have to go back and look at pictures and say, well, where was this? Where was that? Where was this? Where was that? It's a whole lot easier to just leave it, take pictures of everything, go, and then wire for wire, do your transfers. So I'm gonna get those parts, and we're gonna roll on. All right, so I'm back from the parts house. They did have the OEM part, right? OEM is a term I've been using and realized, so that means original equipment manufacturer, right? So it means this exact capacitor was in it. Instead of putting in an aftermarket, I want an OEM. In this instance, you'll see that this capacitor has a discharger on the top. The old one has a discharger on the top that actually looks like it's clouded out. And the aftermarket one that would have fit this didn't have that. So I paid a little more, but I have the OEM part to know that it's not the part I'm putting in that's going to create a new problem. While I'm changing start components, I'm changing them all. So they had both capacitors. This relay I want to change. They don't have it. I did find it online, so I'm going to order it. And also this contactor, we'll open it up and take a look at it, but you see kind of that char on the front of that plastic. I'm interested to see how bad this contactor is. So I'm definitely going to order that and replace it, but today I'm going to replace both of these. We'll take them off and test them just to show you how to do that, and then we'll get the relay ordered. So this is like a tar This is not something that's gonna wipe off. So that being said, I'm actually gonna replace these. I'm gonna make a new jumper, cut this, put a new head on it, rather than trying to reuse this and hope we get a good connection. So let me grab what we need to do that. Okay, so I've made a new jumper end here. So we're gonna go wire for wire. This was here, that was there. So it's always important when you're dealing with capacitors to discharge them. It's not gonna spark or anything on you, but make sure you take a screwdriver or something and connect the two. That's gonna discharge the power that's in it. Otherwise, even with your power off, it's a capacitor. It's designed to hold power. I actually made one little alteration here that I'll show you, is that this connection was both red wires that were running into here and then jumping over. So I didn't have a crimp that was gonna take both wires safely. So it's irrelevant. You can put one terminal here, right? This is side A and this is side B. They're all connected. So this can be this way, right? And you're still jumping A to A. Doesn't matter. Also, the sides are irrelevant. There's not a positive and a negative. As long as one side runs to one side and vice versa, you're good. So we go wire for wire. That way, no mistakes. Also, obviously, take pictures before you go. That makes it easier when, as crazy as it is, I mean, I have taken a picture and gone, oh, I'm not gonna need this. And then something happens, you get a phone call, you get a text, whatever, you get distracted. And you go, oh, is this right? Or better yet, you just do it thinking it's right, and then blow something out or it doesn't work. So, all right, so there is those. I'm gonna put this disconnect back in. And she fired right up. Compressor's running, all is well. So, again, I'm gonna replace that relay. This crud, I was thinking I could just wipe it out. I cannot. So, I'm gonna let this run for a little bit, pull down the temperature. Then I will get into any other issues I see. I'll pull that apart, take a look. I'll show you what that looks like. But for now, that was it. Most of the time with refrigeration, when I say most of the time, I mean, it's electrical. Very, I don't know, I feel like very little is it Freon. Most of the time it's an electrical wire that's short. I do have a question about this. So, I've done no work on this unit, but some warranty work was done on this unit when it was short cycling, and they came out and took care of it. And I wonder if by took care of it, they mean they cut out the low pressure, because it looks like the low pressure is now running up, right? I mean, obviously these blue wires were connected here, which this is on the suction line. Now they're connected to these wires, which are on the discharge line. So very different. And this is a cutout, right? This is a low pressure cutout right here. This should be connected to the low side, not the discharge line. So for now, let's let it pull down to temp, and then we'll revisit the rest of this mess. All right, so our unit is still running. Temps are pulling down. I wanted to show you quick about these capacitors. All right, so this capacitor says 40 UF plus or minus 6. That's like microfarads. So every meter is a little different. Sorry. For mine, we switch it to this. And then it starts with ohms and continuity. I hit mode. If you can see, this is more ohming things out. This is the continuity. One more mode. Hey, this little NF. Sometimes it's a UF. That's microfarads. So with that set to microfarads, if we take our leads and put them across the top, it'll take a second. 41.6. Well, this should operate at 40 microfarads plus or minus 6%. So that is a good capacitor. Still good. So this one, I had to clear some spots so I could make contact, but there and there, we got contact. It's gonna say OL, and then it's gonna wake up, or it's not. So in this case, it's not, because it's burnt out. So when you test a capacitor and you know you've got good contact, and you get OL, it's over limit, it's done. So that thing is burnt out on the inside. That's how you can test a capacitor. You know, visually, we obviously know this capacitor was the problem and it's shot. But if they looked good and then you tested it and you got OL, you would know, hey, I got a dead capacitor. Yeah, done. So, update. The compressor's dropping in and out, but just the compressor. So again, if it was high pressure, low pressure, it would be killing the fans. It's just the compressor. So is the compressor shutting off on thermal overload? Well, the good news is I've got an identical unit right next to it. So what we can do, we can get the FLIR. Okay, we can look at the temperature of, yeah, I mean, my compressor is not stupid hot. 113, 114, and it's shut down. This one, yeah, it's not off on thermal. This thing's running 175 degrees, and it's still running just fine, 184. So this compressor should be running at those temps. So it's not off on thermal. It's thermal, it's just like an internal temperature breaker inside the compressor to keep it from burning out. It's maybe that relay that I didn't get changed today is the culprit. Let me do some homework. This is why it's important to not just walk away. This thing ran for 15 minutes. It seemed like it was running. But, you know, fortunately, you gotta hang out, wait for it to satisfy, wait for it to come back on. This is why this isn't fixed. Okay, the best situation ever to deal with is to have two pieces of identical equipment next to each other when one doesn't work, because you have a good guinea pig to test things. So I tested the voltages across all of these relays, and they're both the same on this one that wasn't working and that one. But you can see I've removed the relay and I've just set it here temporarily and wired it up. So if the internals of that relay are why my compressor is dropping out, I'm gonna find out. So I'm gonna now watch this for another 15, 20 minutes. And if it stays running the whole time, I know I need to replace that relay, and it's worth chasing around town. It's not worth chasing around town to get here and hook up the relay and go, oh, that wasn't it, right? You don't know what you don't know. And I'm not sure that relay is the problem, but I know when you replace start components, you should replace all of them. My parts house A didn't have what I needed, so I said, well, the heck with it, I'll just replace these and I'll order that. But I may have to parts house B to get this thing operational if this stays running. So, update to follow. 15 minutes later, no dropping out yet. I figured if it's going to, it'll drop out now while I'm filming. I've been making some phone calls, and there is a parts house about 20 minutes away that has the relay I need. So I am going to put this relay back over there. And the reason is all of the product has been moved out of this freezer into that one. So pulling it down for 15 or 20 minutes didn't hurt anything. But me getting this one to temp and losing that one while I'm gone is dumb. So I'm going to go ahead and put that back, and then we will be back with the relay. Okay, so OEM relay. So there's one screw down here in the bottom, taking it off. Remove that. Remember, I'm a big fan of eliminating my possibility to screw up. So I'm not going to unwire anything. I'm going to reconnect this in its proper location, even though this is stupid simple. And you would think you would go, oh, I get it. Blue, yellow, black, blue, yellow, black. Just do it this way. Right? So, blue on the top, yellow on the bottom. Black on the horizontal. Okay. Complete new start components. Now, let's see if she runs continually and if she satisfies. So, we are now 0. She's satisfied. On the roof, I watched it stop and satisfy, and then waited a few minutes till it came back on and then satisfied again. So, we are now good to go. Point of note, on the sides of these, there's a safe throttle bubble. They don't want you storing things taller than that because, for example, they're blocking the fans with their boxes, so you're not getting good air circulation. It's drawing in from here. So what will happen is this will reduce the amount of air coming in, and then the coil will freeze up for lack of airflow. So we will talk to them about that, but we're good to go.